A very good morning, sir. My name is M. Varshasri, and I'm currently pursuing third BTech first semester in CSM branch. And today I'm here to give a presentation on the topic semantics, binding, scope, and the memory. And the subject name is operating systems and system programming. Today's my topic is all about the semantics, binding, scope, and memory. The first one, we need to know about what the semantics actually is. The semantics refers to the meaning of the valid statements in a programming language, while syntax defines how the code must be written, whereas the semantics defines what the code actually does. For example, when we take x is equals to x plus 1, syntactically it is a valid statement in C. But when it comes to semantics, it tells that it increases the value of x by 1. Semantics refers to the meaning and the interpretation of programming language constructs. The semantics ensures that both the compiler and the programmer understand the logical meaning of each expression and the statement. It defines how the expressions and the statements in a program behave during the execution process. It also helps in predicting and reasoning about the program behavior efficiently. The types of semantics. There are two broad categories of semantics. The first one is static and the second one is dynamic. Here we are going to learn first about the static semantics concerned with the rules checked at the compile time. It also includes type checking, scope rules, and declaration checking. For example, an undeclared variable or type mismatch causes a compile time error. Whereas in the case of dynamic semantics, it is concerned with how the programs behave at the runtime, describes what happens when the code is executed. For example, the division by zero or accessing the invalid memory or the dynamic semantic errors. There are other formal approaches includes such as the denotational semantics, operational semantics or the axiomatic semantics. Clear understanding of both the types helps in designing the correct and efficient programs. The binding concept. The binding refers to the process of associating program entities like the names, types, or operations with their actual meanings or the implementation. When a variable or a function is declared, it is bounded to a certain attributes such as a data type, a memory location, a value, or a scope or lifetime. For example, in int a is equals to 10, the name a is bounded to the type int, whereas a is bounded to a specific memory location and it is bounded to the value 10. Binding, it can occur at different stages like early, which is the static binding, or the late, which is mean the dynamic binding. Proper binding ensures that the variables refer to the correct data during the program execution. Static versus dynamic binding, which the static binding, which is also called as the early binding, occurs at the compile time. The compiler determines the type method or the variable that will be used. It is also a faster execution because all the bindings are fixed before the program. Example, function overloading in C++. Whereas in the case of late binding, that means the dynamic binding, it occurs during the runtime. The actual functions or the variables is determined based on the current context, which provides the flexibility but can be slower. For example, virtual functions in C++ or the polymorphism, that means having more than one forms in the Java and Python. The choice between the static and the dynamic binding impacts the program flexibility and the performance. The scope of variables. Scope determines where a variable can be accessed or modified within a program. It defines the visibility of the identifiers. The types of scopes include the local scope, global scope, the block scope. The first one is the local scope. Variables declared inside the function or the block where they can be accessed only there. Whereas in this case of global scope, variables declared outside all the functions and they are accessible throughout the program. The third one is the block scope. Variables defined inside the flower braces are only available within that block. Proper scoping ensures that the variables do not unintentionally interfere with each other. Proper scope management prevents naming conflicts and unintended side effects. The lexical versus dynamic scope. The lexical scope is determined by the programmer's physical structure, can be inferred from the code layout. It is determined and the compiler decides whether a variable references based on where they are defined, and it is common in most of the modern languages like C, Java and also the Python. Whereas in the dynamic scope, it is determined by the sequence of function call at that during the runtime. The program searches for the variable values in the call stack rather than the code structure, and it is found in some older or the scripting languages such as the Perl. Modern languages uses this lexical scope for its predictability and the easy of understanding. The memory management in the programming. Memory management refers to how the program allocates, uses, and free memory resources. Main memory areas are used by the programmers. The stack memory, which is used for the function call and local variables, and it automatically manages the allocated and freed by the system. The heap memory, uses for the dynamic memory allocation managed manually or automatically in the case of Java or Python. The static or global memory, used for the global and the static variables that persist for the entire program. Efficient memory management avoids issues like a memory leaks and the segmentation faults. The lifetime variables and the storage classes. The lifetime variables defines how long a variable exists in the C or C++ languages, which stores the classes control both the scope and the lifetime. Automatic, that means auto, which is also defined as the default for the local variables, created when the function starts and destroys when it ends. The static retains value between the function calls. Scope can be local or global depending on the declaration. The third one is the registers. Suggests storing variables in CPU register for the faster access. And the fourth one is external, which is also known as extern, refers to the global variables defined in another file. The impact of semantics and binding on the program design. The clear understanding of semantics ensures that the logical correctness and prevents runtime errors. Proper binding improves modularity and reusability of code. The correct syntax and the binding rules enables predictable and bug-free code development. Effective scope management avoids variable naming conflicts. They influence the language features like polymorphism, encapsulation, and the modularity. Correct memory management leads to efficient, the stable programs. These factors together contribute to code readability, performance, and maintainability. Mastery of scope and mastery of concepts leads to better resource management and program robustness. The summary and the best practices. The clear understanding of semantics, binding, scope, and memory is an essential for effective programming. They declare variables close to where they are used and also limit the usage of global variables, preferring the lexical scoping for predictable behaviors. Use appropriate binding techniques and scope rules to improve the code clarity and maintainability. Use static binding unless runtime flexibility is always necessary. Always free dynamically allocated memory in the C language or C++. Regularly review the memory management practices to prevent leak and optimize your performance. The follow consistent naming conventions and indentation for the clarity. Use tools like the garbage collectors or the memory profilers to avoid these such types of leaks. And it also improves the performance of a program and how a program must be written in order to prevent from all the fraudulent things that happens during the execution or during the compilation time. Thank you for giving me this opportunity.